Hello guys, so today I'm going to be talking about the charge tape lab that we had to do for Physics 2. And yeah, my name is Montelos Benavichus, so let's get into it. So the purpose was to analyze the motion of charged particles on a piece of tape in order to understand the effects of charges on each other, because there was two different tapes that were charged, and so you were taking a look at how they would affect each other. And so you're pretty much just learning how to measure excess charge. Now the setup was you had one piece of tape hanging from two elevated surfaces and the other one was held in hand. To understand all the concepts for this, you needed to understand Newton's second law, Coulomb's law, and pretty much just understanding how gravity and electric fields work, especially in terms of point charges. And in order to model this, we also used a GlowScript model. So the physics explained, pretty much you needed to know Coulomb's law and the force of gravity. So force of gravity is m times g. Coulomb's law, as you can see written on the screen, the electrics, it's pretty much just looking at the electrostatic force, and you do Coulomb's constant multiplied by the values for the two charges for each of the objects, and then all over the distance squared, and you set that equal to the force of gravity, just because they're going to equal out each other in the situation. So the assumptions that we have is that the base tape and the U tape are both 0.2 meters long, or 20 centimeters. The density is about 1 gram per meter, which was given to us during lab. And then the mass of the tape is 0.2 times that 1. So pretty much it becomes 0.2 grams. And we just had to measure everything with a meter stick, so there could be some imperfections there. The procedure was that we needed to cut up 20 centimeter strips of clear tape, fold them, stick it flat to each other, place another tape on top, smoothing it out, peel it off, and that's supposed to charge it. Now you end up doing that and then testing it against your hand to see if any attraction occurs. If nothing happens, that means you didn't charge it properly and you need to redo it. So you do that again. In order to also create a charge, you would rub it on clothes and hair to create some sort of interaction, and then use that to determine whether or not it's carrying a positive or a negative charge. And then you ended up setting up the U tape so that it would float against the other one, and then you would pretty much do the experiment to determine how much of a distance the two tapes would move away from each other against the force of gravity, what the separation would be. And then you use that to find the excess electrons and total number of electrons. So the GlowScript code is over here. It was pretty much just modeling exactly what I just said we did in the experiment. So it's finding the values of the charge and then pretty much just adding that together with gravity and counteracting it so that it's set equal to 0. And you can see the point charge variable there. Now, in conclusion, these were the calculations that I had made, and you end up getting that there's about 4.6117 times e to the 11th excess electrons, and then you calculate 5.12 e to the 17th atoms. There's a lot of different sources of error that could occur. Some of these are the gravity and the electric force could be not just the only two forces acting there. Then charges of tapes could vary. You could accidentally touch something and create a different charge on it than it was supposed to. Now, what if electrons had positive charge and protons had negative charge? How would this change stuff? Pretty much it wouldn't change much as long as they're both switching like that. All it means is that if they were opposites, they would attract. If they were similar, they would repel. And then why is it important to handle these tapes as little as possible? And that's just because you want to make sure you don't accidentally ground them or change the value of their charge. But yeah.